Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts from mathematics, especially the topic linear algebra. And today we are going to talk about the concept of rank of a matrix. So what exactly do we mean by rank? Now there are different ways to explain this concept. For example, we have earlier learnt about echelon form of a matrix. So if you recall, in echelon form we have certain properties for that matrix, that all the zero rows should be at the bottom of the matrix and first non-zero entry in each row has to be to the right of the leading entry, which is also called a pivot, and all the elements below a leading entry need to be zero. And there we had also mentioned that an application of this matrix is finding the rank of a matrix. So if you basically have a matrix and then you go to its echelon form, then the number of non-zero rows is going to tell you what is the rank of that matrix. So for example, if you have a unit matrix itself, then the rank is straightforward 3, because this is already in its echelon form. In fact, it is in the reduced row or row canonical form, but you know here that the rank is 3 itself. But you can have another matrix and then you can perform row operations on that matrix, and step by step when you perform them, finally you get this particular matrix, and then the non-zero rows of the echelon form are noted, and from that we are able to determine what is basically its rank, and there here, since there are 3, it will be 3. Now the maximum number of linearly independent columns or row vectors of a matrix are also basically the rank. Now here you see a matrix, 2 by 2 matrix, and 1, 7 are the elements in the first row and 2 and 14 are the elements in the next row. But here you would notice is these are not linearly independent, because you can see clearly that the second row is a multiple of the first row. If you just multiply it by 2, you are going to get the second row. So here we have to look at only the maximum number of linearly independent row vectors, and so here 1 is going to be the rank. Now there is also the concept of minor of a matrix. So if you have a matrix like that, then you can take a square submatrix. For example, this can be a minor, and you can find its determinant, and order of the highest ordered non-zero minor is also the rank. Now rank of a matrix has certain properties, like if it's a singular matrix, that means if its determinant is 0 and the order of the matrix is m, say it's a square matrix m by m, then rank of this matrix is less than m. But if it's a non-singular matrix of order n, the rank is equal to m. Now if it's a null matrix, for a 0 matrix the rank is 0, and for the identity matrix, as we just now saw, that it will be the order basically. So if it's a 3 by 3 matrix like you saw in this case, order is 3, and then in that case rank is also same, that's 3. Now we've already seen that if it's in echelon form, the number of non-zero rows of that matrix are basically denoting, or rather will be used to find out the rank. And here m, if it's in normal form, what is a normal form? It's a matrix, and here you will have an identity matrix as a part of it and other entries are 0. Then in that case you would see that the order of the identity matrix is going to be the rank. What about the situation where the matrix is rectangular? So the order is say m by n. Then in that case, whatever is minimum in both these numbers, the rank has to be less than or equal to that number. Also, if you take its transpose, conjugate, etc., you see that the rank it remains unchanged. And as we had earlier seen, 2 row equivalent matrices are going to have the same rank. Now, to elucidate this more, let us take an example about dependence and independence. So typically I can just write an equation, or I can give a real life example. So let us take a real life example. Say 3 tomatoes and 4 onions together cost rupees 55. This could well be written as 3t plus 4o or 3x plus 4y is equal to 55. So basically, I hope you understand, it's any equation. Then the situation is 3 tomatoes and 5 onions cost rupees 65. So 3x plus 5y is equal to 65. So two equations, 3x plus 4y is equal to 55, 3x plus 5y is equal to 65. Now here you would see that if I just subtract the first one from the other, you get 10 as the difference of the cost and you get 1 onion. So you immediately are able to find out the price. Say here in fact you are finding out the variable y. I had said 3x plus 4y is 55, 3x plus 5y is 65. So subtracting the first equation from the second, you get y is equal to 10. So that is in fact cost of an onion. And then if you back substitute, so the cost of onion is 10, so 10 into 4 is 40. So in the amount 55, remaining is 15, and there are 3 tomatoes. So cost of each tomato is rupees 5. So x is 5. So you have determined both the variables. Here the variables are 2 and the rank is also 2. But what about the situation where say 3 tomatoes and 4 onions cost 55 is same, but next information that you have is 12 tomatoes and 16 onions cost 220. You can clearly see that this second row is just 4 times the first row. So is it giving you any new information? Now think about it from practical point of view. When you know that 3 tomatoes and 4 onions cost this much, and the second line is also giving you the same information. So basically you have that only information, that 3x plus 4y is equal to 55. Will you be able to determine the values of x and y uniquely? No, you wouldn't be, because the data is insufficient. The second row is not given us any new information. So here you see there is linear dependence, so as to say. So there are two variables, x and y, or tomatoes and onions, two variables, but the rank is 1. So that is an example, a real life example of what we were trying to talk earlier. So rank of a matrix is a very important concept. Thank you.